Hey everybody, welcome to our explanation for phenomenon number 18, Mentos plus Diet Coke. Before we get to our question, let's review a couple things that you may or may not know about the ingredients of our phenomenon. So, soda is bubbly because it contains a gas called carbon dioxide. Those are those little white circles in the soda on the right. But the main ingredient in soda is water. Now, these are water molecules in the soda. And what they do is they form a net of water. And what they do is they surround the carbon dioxide. So the carbon dioxide is trapped inside a net of water, and the carbon dioxide is actually dissolved into the liquid in the soda. So I'm going to show you a little bit about what happens when you shake up a soda.
Hi everyone.
Okay, Maya, what's that bottle in your hands?
It's seltzer.
What is seltzer made of?
Mostly water.
But then what are those little bubbles? Mads, what are those little bubbles?
Carbon dioxide.
Okay, so let's see. If you shake it up.
This.
Okay, looks like we see more bubbles. So why do we see more bubbles when you shake it up?
Because it's being released from the water.
What's being released?
The carbon dioxide.
Okay, so when the lid is on, the carbon dioxide will eventually go back into the water. But what happens if you shake it up and take the lid off?
Please step back.
So we got foam coming out. So those bubbles are dying to get out of that soda, that seltzer. Okay, keep watching for more information. Okay, another fact that we need to review is that when something heats up, its molecules move around more. And that will become important when we talk about the warm soda versus the cold soda in our phenomenon. So now back to our question that we're trying to answer, which is, why does the warmer soda shoot higher? But before we do that, let's try to answer this question. Why does the Mentos cause such a reaction in the first place when you put it into the Diet Coke? So the carbon dioxide gas that's in the soda, and we talked about this already, it actually gathers on the Mentos. So you can see these little bubbles, and those bubbles are representing the bubbles that form on the Mentos when you drop them into the liquid. Now, if you look at the Mentos under the microscope, what you'll see are these little things called divots. And it almost looks like a golf ball with these little rounded out areas. And in those rounded out areas, you're going to have the carbon dioxide collecting. So the carbon dioxide collects, it's going to form bubbles, and these are called nucleation sites. Now, when this process happens, it is not a chemical reaction at all, like when we combine baking soda and vinegar. It is not a chemical reaction. It is only a physical change where the carbon dioxide is actually just going to leave the water or the soda. So the carbon dioxide gathers in the holes to form a bubble, and you can see that in the middle of the screen there. That is a big bubble forming inside that hole in the Mentos. So notice the bubbles here that are forming on the surface of the Mentos when we drop them into just regular seltzer. So it's clear, you can see it, but you can see all those bubbles forming on the mint Mentos that's in the bottom of that cup. And bubbles will even form on your skin if you dip your finger in the soda. And you can see Maddie and Maya's fingers dipped in the same seltzer, and you can see the bubbles forming on their skin. So the bubbles are not as dense as the water, so they float to the top. So if you look at our earlier stuff you work with density, you'll understand what that means. But it means basically that it's lighter than the water, and so it wants to go up and out of the water. So now back to our big question, warm versus cold. So Maya and Maddie are going to explain a little bit here.
scientist Maya, and we have my assistant coming again. And thank you for coming to part 2 of our explanation for the Mentos and Diet Coke experiment.
Okay, so what question are we going to try to answer?
We're going to try and answer this question, which is, why does the warmer soda shoot higher?
Okay, so what do we have here in front of us to help us explain this?
So this is some warm Diet Coke, and this is some cold Diet Coke.
Okay, so Mads, what does something look like when it's warm?
Kind of like,
Does it have a little bit of energy or a lot of energy?
a lot of energy.
Okay, so it has a lot of energy. Okay, so Maya, what do you think is going to happen when you put one of those Mentos candies in the warm and one of those Mentos candies in the cold?
I think the warm might explode a little more than the cold one.
And why is that?
Because there's more energy in the warm.
So then the bubbles are going to have more energy to come out of the soda. Okay, so let's see if it's true. Whoa. Okay, a lot of foam happening in the warm. Let's see what happens with the cold. A little bit, but definitely more for the warm. A little bit of energy, a lot more energy. Okay, so keep watching the video for a little bit more explanation of why the warm shot higher than the cold.
Bye guys, see you next time. Bye.
Okay, so as Maddie was saying and Maya were saying, the warmer soda has more energy, so the carbon dioxide can gather more quickly. So warmer bubbles are less dense than cold bubbles, so they rise to the top of the soda and out very quickly. So warmer soda shoots higher than cold soda. So just to wrap it up, why does the warmer soda shoot higher? Well, first, we have the carbon dioxide that wants to exit the soda, and it uses the space in the Mentos to gather up. And since warmer soda has warmer carbon dioxide, it can exit faster and higher than colder carbon dioxide. All right, that's it. Thank you very much for watching. I hope you enjoyed this video. See you later.